Okay, in this lesson we're going to go over fractions, everyone's favorite thing to do in the world. Seems like if there's one thing that people will groan about in class, it's like, hey, let's go over fractions. Honestly, fractions are your friend. I'd much rather deal with 1/7 than the decimal for this. In fact, what is the decimal for 1/7? (0.1428571429). So in a lot of ways, fractions can keep things a lot cleaner, especially later on down the road when you're a lot more comfortable with math and you've got some equation like this, y equals 7x plus 14, and you end up solving, you're trying to find out where the graph touches the x-axis or something crazy, and you find out x is 1/7, and you got to plug it in to find out what the y is. Well, it's a whole lot easier to plug in 1/7 to this, because it's going to end up canceling with the 7, than it is to plug in that ugly thing. So there are times where fractions are going to be a lot nicer for you. So we just want to have a good understanding of what fractions are, how to deal with fractions, kind of how to make fractions work for us. So let's just start with some basics here. So a fraction usually is, the numerator is the top, so it's the number of items divided by, usually it's like a size or the number of people that you're splitting it between. Like, for example, if I've got 4 pizzas and I'm splitting that between 5 of my buddies, 4/5 would be how much each person gets. So I've got 4 pieces or 4 pizzas, splitting it between 5 people. If I want to add, let's say that's not enough pizza, we order another one. So we're going to add 1 pizza. Now I've got total 5 pizzas that I'm splitting between 5 of my buddies. So I would have 4/5 plus 1/5. Each person is going to end up with 5/5. Which would simplify to 1. If I divide the numerator and the denominator by 1 or by 5, that would end up reducing down to a 1. Notice that the denominator, though, is a 5. A common mistake I see when you're adding fractions together is, you add the tops together or the numerators together, 4 plus 1 is 5. But a lot of times will see the denominators, people, they're not sure, they're adding fractions, they see this plus sign, and they're like, oh yeah, 5 plus 5 is 10. Well, that doesn't really make sense, because if I have 4 pizzas split between 5 of my buddies, plus, we order another pizza split between 5 of my buddies, you don't somehow get 5 pizzas split between 10 of my friends. That would be convenient, because I would like 10 friends. But it doesn't actually work that way. The denominator stays the same. That's the big takeaway here. When you're adding fractions or subtracting fractions, the denominator has to stay the same. Unless you want more friends, and then, 5 plus 5 is somehow 10. Okay, so let's just add and subtract a couple fractions. Let's go with 3/4 plus, keeping it simple, 6/4, which could actually reduce, but just for practice sake, we'll leave it. If I were to add them together, I would add straight across. On the top, 3 plus 6 is 9. The denominator stays the same, and so I get 9/4. Pretty straightforward. If I wanted to convert this to a mixed number, so right now it's an improper fraction, meaning the numerator is bigger than the denominator. If I wanted to convert this to a mixed number and find out how many wholes and fractions, I would divide it. So 9 divided by 4 is 2 with some decimals left over. So there's 2 wholes, 2 whole numbers. Then I need to figure out how many are left over. So if I do the 4 times 2, that gives me 8. So it's almost the 9. That means there's 1 left over. So I would still have a 1 in the numerator, and my number of friends stays the same. So that's going to be a 4 here. So 9/4 converted to a mixed number, mixed meaning whole number and fraction combined, would be 2 1/4. Let's subtract. Let's say I've got 1/5 minus 3/6. Now, I don't like subtracting fractions because a lot of times the subtraction sign, I see your handwriting, it's pretty sloppy sometimes. And so this subtraction sign gets a little too close to the fraction bar, and somehow it ends up looking like it's all one line, and then you get confused and you're like, I don't know what's going on. Am I adding? I must be adding. So you just add it, and then it ends up being the wrong thing. So I don't like to subtract fractions. What I do is whenever there's a subtraction sign, I just quickly modify it so that way it's plus a negative instead. Subtracting is the same thing as just adding a negative. So instead of the subtraction sign, I'm going to make that a plus, and then tack on the subtraction sign. I'm just going to make it a negative attached to the 3 on the next fraction right behind it. So now I'm doing 1/5 plus negative 3/6. Okay. The issue I have here now is that the denominators are not the same. So I need to get a common denominator. So we have to do a little mental math for a moment. Look at the 5 and the 6 and try and figure out, okay, well, what is a number that 5 and 6 both will go into easily? So if I'm looking at it, 30 might pop into my head on this one. So I need the denominators of both of these two fractions to be a 30. Now the question is, how am I going to magically change those to a 30? I'm not allowed to just grab an eraser and just magically change it. I have to do something that's mathematically legal, that has the same value. So I'm looking at this 1/5. I want the denominator to be a 30. So if I was to multiply the bottom by a 6, that would make it 30. Well, it needs to be mathematically legal. So if I multiply the denominator by a 6, the only way I can do this legally is to also multiply the numerator by a 6, or the top. So that way, I'm multiplying by 1. 6 divided by 6 is 1. So I'm really multiplying this fraction by a 1. It just is going to change how it looks. Okay, so that's going to make this 6 times 1 is 6, and then 6 times 5 is a 30. So I've changed this fraction into 6/30ths, which is still equivalent to 1/5. If I were to reduce this, it'd be 1/5. It has the same value. It just looks different. And looking different is okay. You just got to remember that. I tell myself that every day. And sometimes twice. It's got awkward, didn't it? And that's okay. Okay, so we got negative 3/6. I want this to be a 30. So I multiply this. You're still thinking about that. You just stop. Just stop. Okay, back to here. Here we go. Negative 3/6. So we multiply this by a 5 to make this a 30. So whatever I do on the bottom, I have to also do to the top. So I multiply the numerator and denominator by 5. Starting to speed up a little bit. Negative 3 times 5 is negative 15. 6 times 5 is a 30. Now I have two fractions that have the same denominator, so I'm able to combine them together. So I've got 6 of these things plus negative, so now I'm losing something. I had 6 of them, now I'm losing 15. 6 plus negative 15 would be negative 9. So I've got negative 9/30ths. So I just combined them, or I added them together or subtracted, however you wanted to think of that. The only issue now is I need to reduce the fraction. If you ever have a fraction, you always need to reduce it, always. Try to reduce the fraction. So negative 9 divided by 30. I need to think of a number that divides into them both. So 3 is coming to me, so I'm going to divide the top by a 3 and the bottom by a 3. So that's going to be a 10. 9 divided by 3 is 3. 30 divided by 3 is 10. So now my final answer here, I'll put it down here so I can see it, negative 3/10. Okay? So we just combine that. Notice I put the negative attached to the 3 up here instead of out in front of the fraction so I could see it and it doesn't somehow magically disappear. How we doing? You doing all right? Let's do another one of those. That was good. It was a good time. Okay, let's try this one. We got 4/9 plus 5/6. Okay, well, I need a common denominator. So some people would say, well, you just multiply the other one. You multiply this one by 6, multiply that one by 9. There is a shorter or a smaller number that works. 18, 9 and 6 both actually go into 18. So that will help us have some smaller numbers, maybe easier to deal with. So to get an 18, I want to multiply the 9 by 2. So I'm going to multiply the top and the bottom by 2. To get 6 to be an 18, I multiply the top and the bottom by, good, excellent, well done. So this is 8 over 18. This would be 15 over 18. Now I can add them together. So 8 plus 15 is 23, divided by, do I add the 18s together? Careful. Got to check my other video if you need to. Okay, stays 18. My friends don't somehow magically become 36 friends, even though I want it to. No, the denominators stay the same when you add fractions together. Okay, if I needed to somehow convert this to a mixed number, how did I do that? Divide it. So 23 divided by 18 is 1 and some ugly decimal. So I have one whole number. How many are left over? Well, if I subtract them, that gives me 5. So there's 5 leftovers. And then the denominator stays the same. So it depends on what answer you're wanting. If you're allowed to do an improper fraction, you'd have that. If you need to have a mixed number, then there you go there too. Okay, so that's adding and subtracting fractions. But what if we change things and go to multiplying fractions? Multiplying fractions is fun, in a very nerdy kind of way, of course. Let's just do some simple numbers. 2/5 times 3/7. When you multiply fractions, you go straight across, and you multiply both. Okay, so the numerator is 2 times 3. So we've got 2 times 3 on the numerator. The denominator, 5 times 7. So now I'm looking at it. Now I really want to just multiply them straight across and get 6 divided by 35. I do usually hesitate right here just for a moment to make sure that nothing reduces. So sometimes like this 2 will reduce with one of the numbers on the bottom. Or maybe the 3 will reduce with the number on the bottom. And that will make it so I don't have to reduce it later. Like for example, let's do one here. Let's go with 4/11 times 9/10. Okay? So if I've got 4/11 times 9/10, I multiply straight across. Now before I actually multiply the numbers, I'm just going to write them down next to each other. And then I look at the 4. Does it reduce with anything on the bottom? Yes, the 10. So 4 and 10, they both have a 2 in common. I could divide them both by a 2. So if I divide them both by a 2, 4 divided by 2 is 2. That becomes a 2. 10 divided by 2 is 5. So I've replaced the 4 and the 10 with a 2 and a 5. So now I look at it again. Does anything else reduce? I got 2 and 9, 11 and 5. Nothing else reduces. So that's as simplified as I can possibly get. So now I am allowed to just multiply across. 2 times 9 is 18. Divided by 11 times 5 is 55. What would have happened if we didn't reduce here? So if I did 4 times 9, I would have had 36. And 11 times 10 is 110. And I have a lot of students that would have seen this and just thought, oh, that's my answer, I'm done, and they move on. Well, it's a fraction. Anytime you have a fraction, you have to reduce it. And so we'd have to look at this and say, okay, well, what number goes into them both? 2, and then I'd reduce it and still get the same answer as I did with this first method. But I feel this way is a little easier to make a mistake. So if you can, try to reduce here, especially when the numbers are big. It's going to be a lot harder to do later on. Multiplying fractions. Well, that leads us to dividing fractions. Dividing fractions, let's go with something that we would think is easy. 1/3 divided by 2/5. Is that not one of the ugliest looking things you've ever seen? That's ugly. You really don't want to divide fractions. So even if I wrote this to look a little nicer, it's still just putting lipstick on a pig. No offense to pigs. Actually, that's still offensive to pigs. Hopefully they don't hear this. Don't show any pigs this. 1/3 divided by 2/5, that's still not, I mean, it looks nicer, but it's still not ideal. You really don't want to divide fractions. There's a saying that says, dividing fractions is as easy as pi. Flip the second and multiply. Dividing fractions is as easy as pi. Flip the second and multiply. So what it's really saying is dividing fractions isn't as bad as you think. All you have to do is flip the second fraction upside down, or take the reciprocal, is the technical word, and then change this sign to multiplication. So this would be 1/3 times 5/2, and now we can just multiply straight across. In this case, nothing's going to reduce, so I'm going to get 5/6. Boom, shakalaka, 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 shakaboom. And you got your answer. Okay, dividing fractions is as easy as pi. Flip the second and multiply. Let's try another one of those. Good times. Good times. 14 divided by 9 divided by, so I got 14y over 9. Let's go with 2y divided by 12. That looks fun. I know I could reduce this right now, but just for practice sake, we're going to go ahead and write this. So really, I don't like seeing this. It's just too ugly. So we got 14y over 9 divided by 2y over 12. Dividing fractions is as easy as pi. Flip the second and multiply. So we got 14y over 9 times 12 over 2y. And now I can try and reduce before I multiply across. It's going to make it a lot easier for us. So what would actually reduce here? So we got 14 and 2. They would kind of reduce. So the 2, if I divide them both by 2, that turns into a 7, and that goes to a 1. What else? 12 and 9, I could divide them both by 3. So that would become a 4, and that would become a 3. There's still one more thing that you can do, though. And that's the y's. Good. Now there's one y on top, one y on bottom. In this case, they would reduce. I divide them both by a y, and they both cancel. They both go away, which is nice. So what's left over? In the numerator, we have 7 times 4, so 28, divided by 3 times 1 times 1, just 3. Does 3 go into 28? Not evenly. So if I'm allowed improper fractions, boom, I'm done. If you need a mixed number, divide it. So 3 goes into 28 9 times. How much is left? 1. Because 3 times 9 is 27. So there's 1 left over. So I would have 3 and 1/3 if I needed a mixed number. Okay, let's do a fraction equaling a fraction. We're almost done with this. Just trying to show you a few things to do with fractions that will help you become a little more comfortable around math. Fraction equaling a fraction. 1/2 equals x over 4. Okay, even something as basic like this. Anytime you have a fraction equaling a fraction, you don't want to add across, you don't want to multiply straight across. The method that a lot of people use with a fraction equaling a fraction is to cross multiply. Okay, so if I cross multiply, 1 times 4 is 4. Then I put an equal sign. Remember, the equal sign can't just disappear. If the equal sign was in the problem, it's got to be there as we go. So 1 times 4 has to equal 2 times x. I've heard of the butterfly method with this, where you draw a butterfly and it's pretty and you use colors and just pops. Or not. Just cross multiply. So we got 1 times 4 is 4, 2 times x is 2x, and then if you're solving from here, you try to get x alone. Right now we have 2 times x, so to cancel multiplication, we would divide both sides by 2. So that cancels, and 4 divided by 2 is 2. I still have an x on this side of the equal sign, and there's nothing else to do, so we've solved for x. But cross multiplying will help when you have a fraction equaling a fraction. Let's do an example. Let's try and confuse you here. Make this kind of a complicated one. Let's say we've got x plus 3 here over 5 equals 4/7. Something fun. Well, I have an x plus 3 on the top of the fraction. This kind of scares me a little bit because when I cross multiply, what are you going to multiply? So let's just start with the 5 and the 4. That's simple enough. 5 times 4 is 20. Good. Equal sign. Now I multiply here. 7 is being multiplied to both of these things. So technically there's actually an invisible parenthesis around this x plus 3 because both of these are being divided by the 5. So when I multiply the 7, I have to distribute the 7 to both of these. I mean, if you really want to see it, would be like this. 7 parenthesis x plus 3. Then I would distribute the 7 into the parentheses. Don't be racist. Make sure you do it to both of the things inside the parenthesis. So we have 20 equals 7x plus 21. And then we would solve for x. Got the equal sign here. I'm trying to get x alone. So I'd subtract the 21 over to the left. So that would become -1 equals 7x. How is the 7 connected to the x? Multiplying. So I would divide both sides by 7. And so then I'm going to move this up here. I end up with -1/7 equals x. I personally prefer fractions. If you really want to write the decimal to this, good luck to you. Make sure you find out where to round it, because this decimal doesn't stop. It's like a party. Or not, yes. Okay, so there's just some basics on fractions. Hopefully that helps you out. If you have any questions, let me know. I'd love to help you. Other than that, stay safe and have a good day.